How I use spaced practice in science. What is it? Spaced practice, also referred to as spaced learning, distributed practice, distributed learning, and the spacing effect, applies the principle that material is more easily learnt when broken apart by intervals of time. While spaced practice is thought to make learning more challenging for pupils as it prohibits information being held in the working memory, it may be able to increase the likelihood of knowledge being embedded in pupils' long-term memory. What does the evidence say? There is evidence to suggest that spacing teaching and learning of material over time, and between intervals of unrelated content, has the potential to improve pupil learning. More studies have examined the impact of spacing content across days and lessons than within individual lessons. Regarding the former, the evidence suggests a small positive impact across pupil ages and subject areas. A very limited number of studies examined spacing within lessons. These suggest promise, but there is too little evidence to have confidence in this result. Spaced practice versus interleaving. Spaced practice is similar to the practice of interleaving, which also involves the use of spacing in a sequence of learning. This said, where spaced practice uses intervals consisting of unrelated content to encourage pupils to temporarily forget information before recalling their long-term memory, interleaving is more likely to be used to systematically switch between concepts and learning that are interrelated, encouraging learners to make distinctions and connections between similar yet slightly different learning material. An example from secondary science. Why I use it. When teaching vast curricula full of complex ideas and vocabulary, devoting sufficient time to retrieving and revisiting key concepts at spaced intervals can be a daunting task, yet it is crucial for long-term retention of knowledge. Using starter quizzes as retrieval activities is helpful, but I too often find that my students cannot remember key ideas or vocabulary from one lesson to the next. The gap between learning in one lesson and retrieving in the next is too long. How I use it. I have been using Ebbinghaus forgetting curve to consider how to make my students more successful in retrieval activities, boosting their learning and confidence. I have embedded spaced practice within lessons to provide an initial retrieval opportunity after a shorter window of time, often 10 to 15 minutes. I have observed that substantial forgetting can occur in only 10 minutes, and that retrieving knowledge after this length of time provides a boost to what students can remember during the next lesson. A recent example from the classroom. Recently, I started a unit on waves with a Year 10 class. The students need to be able to recall the lengthy and complex definitions of transverse and longitudinal waves. I introduced the topic and showed animations of each type of wave, and students copied a definition which I annotated under the visualizer, highlighting and defining the key words. I also asked lots of questions to check for listening and understanding and to help students make links between the definitions and the animations. Following this, I gave students time to read the definition to themselves and try to commit it to memory, then we all closed our books and they rehearsed the definition. This can be done in pairs, speaking aloud to each other, using mini whiteboards, or through cold calling where I ask a large number of students one by one until I decide there is a high level of success. Next, I moved on to a different but related concept, frequency and time period of waves. This involves some definitions and a simple equation, with some scaffolding and examples using mini whiteboards. After 10 to 15 minutes, we returned to the original idea of transverse and longitudinal waves. I asked them all to write the definition of a transverse wave on their mini whiteboards, without looking first. We then checked our answers against the correct definitions, closed our books, and did it again until we could do it perfectly. Even those who could say or write it perfectly earlier found this memory task more challenging, because substantial forgetting can happen in just 10 to 15 minutes. Choosing key knowledge. Drawing on the benefits of spacing within a lesson reduces the challenge of appropriately spacing content across days or lessons within rigid curriculum plans and timetables. While there isn't time to do this for every piece of knowledge that must be taught, I prioritize the spaced retrieval of identified threshold concepts and key vocabulary, which I think will make the largest difference to student success in my subject. Reflection. I find that incorporating this initial retrieval task into the same lesson is more beneficial than simply waiting until the next lesson to start retrieval, as the students are more likely to be successful. I also find that the students actively retrieve the knowledge, rather than simply trying to find the definition in their books, which I hope enables the transfer of the new knowledge into long-term memory. I believe this increases the likelihood that students will remember the definition next lesson, when it can be retrieved again either in a starter task or during later independent work. I can then design further retrieval tasks with increasingly large gaps of time in between, according to a Binghaus forgetting curve. Pip Goodwin is a science teacher in Norfolk, specializing in chemistry. They are currently interim assistant headteacher of teaching and learning at Wymondham High Academy, overseeing CPD, ITT, instructional coaching and all things teaching and learning. They are particularly interested in putting principles of cognitive science into practice in the classroom. Their pronouns are they, them.